Okay, this is a continuation of section 1.5 from MAC 1105. We're looking at various ways to solve quadratic equations, and in this section thus far we have looked at many examples for factoring to find the two solutions. We then went on to look at the procedure of this called the square root property for finding the two solutions. The third method that we looked at was called completing the square. We just did a couple of examples of that in the last video. And now we go on to the fourth method, which is using the quadratic formula to find the two solutions. So you have the formula, which you've seen quite often in other classes at this point. Opposite of the b value, plus or minus square root of b squared minus 4 times a times c over 2a. And this is where you find the a, b, and the c value. It has to be in general form, just as if you were doing the factoring method. These two methods require that you get everything on one side zeroed out on the other side. Then you'll be able to tell what the a, the p, and the c is. A is the coefficient of the squared term. So in this problem, this is a. The b value is found in front of the x to the first degree term or the linear term, and then the constant is the value that has no variable next to it. The sign in front of these numbers, whatever they are, goes along with the a, is part of the a, b, or c value, so be careful with that. All right, so if we're looking for solutions to this problem, we would just follow that formula. There's no factoring, there's no completing the square, we're just using this formula. So it would be opposite of the b value, plus or minus b squared, which would be 4, minus 4 times the a value times the c value. The a value is 8. The c value is -1. Be careful with keeping the signs with the numbers as you put them into the formula. And then that's all going to be divided by 2 times the a value. Okay, now from here, we're just going to continue to try and simplify this. So we have a -2 out front, plus or minus. What's going on inside the radical is 4. Negative times another negative down the way, all part of this product. -4 times 8 times -1. Negative times negative is going to be positive. And the number that you're going to get here is 4 times 8 is 32 times 1 is 32. We've already taken into consideration the negatives. So that 4 times 8 is 32. Of course, that denominator is 16. I'll finish this down here. So this would be -2 plus or minus square root of 36 divided by 16. Sometimes the number underneath here will be a perfect square. Sometimes you'll only be able to take a partial root. Sometimes it'll be imaginary number. So be looking for any of those things to happen. So right now, this is a perfect square, so it just comes out as an integer. There's the square root of 36 plus or minus in front of it, which is going to allow us to get two different answers. Continue. If these are both integers, you'll actually be able to continue to get the two final solutions. So -2 plus, you'll be able to continue simplifying, I should put it that way. So -2, I'll do the positive one first, plus 6 over 16. That's going to be one of our answers. Or the other solution is -2 minus 6 over 16. So let's see, this would give us 4 over 16, or just 1/4. And the other one would be -8 over 16, or just -1/2. So those are our two solutions. You can put them in a solution set, or you can, you'll list them the way they ask you to. So that is your first example of using the quadratic formula. Let's go on to the next page. I think students find that fairly easy, which is why I'm not going to, belabor the point there. Okay, so now there are some problems where there's fractions in them, and you have to deal with that before you can decide which of the four methods you would like to use in order to find the solutions. So this has the extra level of getting rid of the denominators, which requires that you find the LCD. So we're going to look for the least common denominator. All of these various denominators that you see here, you need one, each different denominator that you see that has to go into the LCD, so that when you multiply each of these expressions by that LCD, it always gets rid of the denominator. So we're going to need a plain X in our LCD. We're going to need a 4. I should have written that first. We're going to need a 4. We're going to need a plain X. And then we're going to need an X that is part of an expression. It's connected to another number by a plus sign. That's considered completely different than just a plain X. So each different denominator, every time you see a different denominator, that gets thrown into the LCD to form a product. And this is what you're going to multiply each of these fractions by. So let's write that LCD in front of each one. So it's 4x times x plus 3 times this fraction. Use it. You're going to use it on each and every term, whether those terms are fractions or not. This is an equation, and whatever you do to one term, you must do to all terms. So here I am using it on each and every term of the equation. Okay, in this first case right here, let's see what cancels. Just the x, just the plain x. You still have 4 times x plus 3 times 1. You multiply all the leftovers, but you will not have a fraction if you devise your LCD properly. Okay, then when you come to this next one, you're multiplying again the LCD times this fraction. This time the expression x plus 3 cancels with the denominator. You're left with 4x times 1. Drop down that plus sign. 4x times 1 is 4x, so you have no fraction here, no fraction here, and you're about to get rid of the fraction here. Here, just the 4's cancel. And you're left with x times x plus 3 times 1. And that's where you're going to create a quadratic equation, since the whole section is about quadratic equations. So you're going to have, let's start unraveling all of this. 4 times x plus 12. Plus another 4x right here. And then over here we have x squared plus 3x. Again, distributing each time that you want to get rid of a parenthesis. Now I would get everything on one side, and then you can decide what kind of method you want to use in order to finish this problem. If you want to get everything on the right, you can do that, or you can get everything on the left. If the x squared is positive right where it sits over on the right hand side, I would bring everything over to join it, although you are completely free to bring it over to the left, but it will be negative at that point. Okay, so let's see. We have 8x on the left-hand side, and we're going to bring it over here. So it will become negative 8x. So I just moved both of these terms at one time. I'm also going to move the 12 over here, at which point it will become negative 12. So I've gotten this in general form, just zeroing it out on the left-hand side. Everything is now over on the right-hand side. And I have x squared on the right-hand side. I have these two combined giving me negative 5x, and I have a negative 12. Now, if you can factor, my preference is to factor, but you might like quadratic formula. You can do it either way. You can complete the square if you want. What is not available is using the square root property right now as it is, because you have that linear term. Square root property is when you have just a squared term and a constant. So I'm going to try and factor. Let's see if it works out. So if you're trying to figure out how to break this up by guess and check, you would have an x here and an x here. If you're trying to figure out how to break this up, you're asking yourself, should I use 6 and 2? And of course, you got to decide who gets the negatives. Should I use 4 and 3? Will any of those work? That's the same thing as saying, is this possible? What numbers could multiply to get negative 12, but add to give me negative 5. Are there such numbers? I mean, if you consider the 6, 2, you could go negative 6 times 2, and yes, that would be like that. That would give you negative 12, but negative 6 plus 2 would not give you negative 5. You could put the negative on the 2 and go 6 times negative 2. That would give you negative 12, and 6 plus negative 2 will give you positive 4. So that 6-2 combo doesn't work. What's the other combo? The 4 and the 3? That's not going to work either. So you can't factor it. And if you can't factor it, you must use the quadratic formula. You could use completing the square, but I don't know how many people are going to really select that as a solving method. It's kind of not preferred. So I'm going to use the quadratic formula because I can't factor it. So finishing this problem, let's see. I guess I'm going to do it up here because I don't want to run into my room for the next problem. So I'm going to go up above and I'm going to use quadratic formula. Okay, so coming up here, I'm going to find the answers for the equation by going opposite of b plus or minus. I'm going to do b squared minus 4 times a times c. I'm just getting myself all set up. And then I'm going to be dividing that by 2 times a. So let's see, looking at what I have here, I'm looking at this being my a value, this 1. This is my b value. This is my c value. And I'm going to be dumping that into the quadratic formula. So the values that we need in the first 2 positions of the formula is this negative 5, the b value. So put that in there. This minus is from the formula. This is the actual number I'm plugging in. So you got a double negative there. You put the b value here again. Then we need the a value here and here. That a value was 1. Then we need the c value. The c value was negative 12. And then from here, we're going to just try and clean this up. If you try to clean this up a little bit instead of writing the whole thing again, yes, you're going to get a positive 5. Opposite of a negative 5 is positive 5. But let's try and clean this up a bit. This would be 25. This would be negative times another negative down the road as you try to find this product right here. So that's going to be a positive, negative times negative. And then just think about 4 times 12, which is 48. And then 25 plus 48 would be, you can put that in your calculator. 25 plus 48, or do it in your head, 73. All right, so plus or minus square root of 73 over 2. And then you can't really break that down. You can't break 73 down because that's a prime number. There's nothing that goes into it. So that's it. That's the end of the problem. See, sometimes you can't go any further just because you can't simplify the radical. If this was something that there was a square root of, then you could take that square root, get the number, and combine it through either a plus or a minus sign to the 5 and then divide by 2. But that stops right here because this is a number that can't be broken down into anything other than 1 times itself, and that's not going to help you. That doesn't get you any further to simplifying than what you have right now. So this is the finished answer. Okay, and then we go to the last problem, which I'm not going to be able to completely finish in this video. I'll have to finish it in the next one, but I'll at least start it. Let's think about the LCD. This one's a little bit more advanced because you have to think about what is hiding inside of x squared minus 25. If you don't remember how to factor that, even though that's in, I think, the next section, the way you factor the difference of 2 squares is you take the square root of the first term, put it here and here, take the square root of the back term, put it here and here, and alternate those signs. So this denominator has x plus 5 times x minus 5. This has an x plus 5. This has an x minus 5. So you need one of each different factor because none of these factors have a power any higher than 1. I'll finish in the next video.